Hello, everybody, and welcome to this webinar dedicated to ICEM Design Experience, the new generation of surface modeling. Today with me, there is Bill Silamianos, our senior industry process consultant based in North America. Hi, Bill.
Hello, how you doing, Fabio? And hello, everyone.
And myself, Fabio Ballari, CATIA Design technical specialist from R&D. So let's start by defining what is the scope and coverage of CATIA Design. When we talk about CATIA Design, we talk about creative design, we talk about surface refinement and product experience. But today, we're going to focus on surface refinement. What you can see here is the dedicated product for surface refinement. On the left, we see the ICEM, which is over the year become the standard for automotive Class A, as you know, and surface modeling. On the right, we have CATIA ICEM, which is the integrated version of ICEM Surf inside CATIA, providing associativity and parametric modeling combined to high-end surface quality standards. And today, we're going to focus on recently released ICEM Design Experience. So with ICEM Design Experience, with this new hub, we really wanted to address two community of users. As you can see on the left, we have CAS modelers, and on the right, we represent the Class A surface modeling. So providing really dedicated tool with a new level of productivity, innovation, and collaboration. Since the beginning of the define of this application, we started by defining KPIs and measure what already exists today in our portfolio. The target was to double the efficiency of today's software in the market. We have based the software engineering on 80-20 rules, providing quick access to the command that ICEM users are using 80% of the time. And of course, focusing on sculpting, quality, measurement, and analysis. But now let's see the software in details. So thanks to the 3D experience platform, creative designer and Class A modeler has directly access to the mechanical engineer data such as body white and engineer, electrical, and so on. The huge benefit is to be able to streamline collaboration between design and engineering and manufacturing departments. We have, first of all, integrated the ICEM Surf navigation in order to help ICEM user feeling home. And we put a lot of effort in improving the user experience in order to get discoverable software from the beginner mode up to the improved efficiency at advanced mode, expert. And some other innovation like universal law, omni technologies, all those details we will see later on. Also, fillet capability has been improved, as well as smart update and performances in order to provide you a very fluid experience in terms of sculpting and update. You see here the new fillet capability that also has been improved, as I said before, snapping capability, and quick access to analysis. All these to provide you the best efficiency and best tool for the Class A and CASA modeling. So you see how the 3D experience platform guarantee collaboration, while ICEM Design Experience is providing the right tool for the right job. Let's see another demonstration. We'll go further in details. So here we are talking about the eVTOL project, a new electric aircraft. And you see here, we start by the project dashboard, where we can store the major information the project team needs to share. Very easily, we can click on the compass and get access directly to the ICEM Design Experience tab. As you can see, the UI has basically been redefined completely. You see the VNav, the palette, the navigation. You also see mouse menu acceleration, quick access to analysis tool. And now we can start by just importing the scan, importing the sketchings, put the sketches on the right scale, on the right position, as you can see here. So we have multiple inputs to start the work. We also have organized managers that help us to organize all those data together. And of course, as we are embedded in CATIA, we can directly load the mechanical and electrical engineer system in our session in order to take, since the beginning, in consideration all technical constraints. You see here also visualization has been improved because now visualization is really part of the design experience. And now let's start the traditional Class A and CAS modeling. You see here, we start by create a section, create a curve, and you see now that we have new modifiers like the global point that enables you to improve the efficiency of the modeling. Very quick access to analysis. We also have an expert shortcut in order to enable user to scale analysis very quickly. We also have stretch view that enable you to be more precise during the modeling phases. As you can see here, we have quick access to modifier by just activating mouse menu. And also we have common panel option variant storage. So in order to enable to store all the options and variants in each common palette. So in one click, you are able to set up all your options for each function. The fictive edge, which is actually a new command, enable you to automatically recognize the theoretical line, as you can see here, on the fly. By clicking on the scan, you're able to define the fictive edge on the fly. Curve modifier box is also part of global modification tools that enable you to modify a curve while keeping the same control point weight. And now you can see that the new high is totally customizable. So you can see here we are able to set up as many commands we need on the mouse menu and then get access quickly. So really the user has the power today to customize the user interface. Omnisurf technologies is another important technology because now based on the user selection, we have one single command detecting the intention of the user. So if you select 3 parallel curves, you will get a loft. If you select 2 perpendicular, you can have a sweep, and 2 parallel as well, blend, and so on. And now we can start the traditional control point sculpting approach to the scan. As you can see here, we have activated section. We have dynamic measurement of the deviation that can be with this maximum value, and also with deviation mapping, real time. You can see here. So we can really precisely being able to approach the scan in this case. Of course, you have seen an approach curve-based modeling, but we can both consider curve-based and surface modeling, depending on the culture you have in terms of surface modeling. You can see that we have quick access to transformation, modifier, rotation. We also have introduced the persistent matching that enable the user to avoid a very annoying task like rematch every time. So here you just have to match one single time, and the soft parameter will take care about rematch and again all the transition you have set up. Same for all the features. Those features are all up to G3 connection. Multi-view picture-in-picture is a new concept, so you can set up as many multi-view you want, and you can really customize and switch from one view to another one, as you can see here, and get closer and closer to the final result. Thanks to the soft parametric, we are also able to have a new approach, a new methodology like the curve-based surface sculpting because of soft parametric. So you create curves, then you create surfaces on top of the curves, and then you can go and directly sculpt on top of the surface control point while always keeping the associativity with the input curves. This is pretty unique in the market and open up to new workflow. Of course, we have introduced snapping capability, universal low control point diffusion that enable you to manage the diffusion of movement on the surface before and after the movement, as you can see here by sliding. And all this combined enables you to have complex assembly context. And thanks to smart update, you really have the ability to have a fluid control point sculpting. And by just modifying this, the soft parametric will guarantee all the transition and all the update you need. So very intelligent and smart. And this, of course, provides you efficiency in design exploration. So no need to rework, just you move and everything is updated. Also, fillet has been improved, as you can see here, with a new low management of the core distance. And as we are embedded in the 3D experience platform, by just clicking on the button, we are able to set up a VR session without any data import and export, and keep going with sculpting and modeling from the outside of the aircraft, but as well from the inside. You can see here, and this is very helpful also to ergonomic study and, design phases. Design and simulation are now more than ever very well connected topics. So you can, thanks to the 3D experience platform, being able to simulate the geometry you have just created by just, again, clicking on the button without any data import and export. As you can see here, we have a review session with the manager in product perception experience, where we notice that we have trouble on the back of the aircraft. So the shape needs to be updated, and directly we can do it in ICEM Design experience, and then replay the simulation and compare side by side the version 1 with the version 2 during design review. As you can see here, we got improved flow, and the new version is, I would say, well optimized. Again, all this without any data import and export. And at any time, you're able to replay the simulation in a VR context, capturing scenes and share with the rest of the team. Visualization is also part of the modeling experience, more than ever. So we have integrated high-end visualization capability by just adding material, background, and scene. You are able to produce very quickly such a kind of realistic rendering, again, without any data import and export. And last but not least, the new human incarnation capability enables you to experience the product and make such a kind of human experience in VR, for instance, for ergonomics in this case. So thanks to the 3D experience platform, we are able to manage from the sketch up to the realistic experience, human experience, the full process end to end. All right, so with ICEM Design Experience, we also wanted to address several kind of population and community. So of course, we start by the CATIA one, which are our history community of user. We also took in consideration ICEM people, and also what we call the morphing, so the people that are more used to global deforming and so on. So with CATIA population, with CATIA community, we take care about Bézier, NURBS, mathematics, feature-based modeling, so parametric modeling, and of course template and so on. The ICEM community is more based on Bézier mathematics, of course, explicit geometry, and I would say direct modeling, generally speaking. And as I said, morphing capability, so the morphing community are people that are more used to global deformation. So I give the end to Bill now to introduce you a little bit more in detail about the new technology.
All right, thank you, Fabio. Hello, folks. This is a short video demo here highlighting some of the innovation delivered deforming geometry in IDX. So we're just going to go ahead and create a simple patch using the accelerator. In a moment here, we're going to go ahead and start making some control point modifications to this surface, just pulling up one end of it. Now, as you can see here, we're going to use a law in a moment to deform it. This is really interesting. I'm going to go ahead and break this law command in a second, as you can see, and I'm going to pull the U and V's individually just to show different ways to deform this using the levers. This is a real efficient way to work. We're not touching the patches, we're just moving control points. We'll go ahead and use an accelerate again and add an additional patch here. And we're going to use some hotkeys here to trace and use an associated match between these two elements. So under control points, I'm going to add a global point manipulator tool. And as you can see, we're going to go ahead and use this global manipulator to diffuse the shape a bit. Notice continuity and constraints between the two patches are preserved during the change. In a second here, we're going to use Grevel points, also to form these surfaces. This is a very, very interesting way to work and very efficient. Last here, we're going to use some torque handles. With these new tools like this, users have new and innovative ways to move and deform and orientate their geometry. As in here, we're going to do some cross-patch modification. Very interesting ways to distribute and slide points back and forth on the sides. And again, this is a very highly productive way to work and deform entities. Here we're using some of the trace commands to use shapes. And again, we're deforming the control points proportionally back and forth, using the associativity and the match to control both sides. Very interesting way to work. Here's a few things to remember about this new application. First, it's really flexible. As demonstrated, you now have very flexible tools that deform and control shapes in a whole variety of ways. Second, you can follow a surface base or curve base approach. This all depends on your profile and your background. You can model using pure Bezier or NURBS. These are all supported using IDX. And my advice, mix the best practices of the different approaches for hybrid workflow. This is in order to have the most control of your model for rapid changes while still achieving the best surface results. Thanks to soft parametrics, we can now keep the associativity while directly sculpting the surfaces. So here's some innovative CAS and Class A technology. Here we have an image that we imported using IDX. This is going to be used as a reference. Next, we're going to create some curves. Again, folks, we can do this in two different ways with Bezier or NURB type curves. Okay, next, we're going to use some of the easy modification tools inside of IDX to streamline our ideation process. Now we're bringing a human in, an autonomous mannequin, and this can be used as a reference inside of our design. Again, we're going to use some of our easy accessible modification tools to quickly make some adjustments. And what you're seeing here is our new Omnisurf technology with soft parametrics. This technology allows users the ability to create some associative shapes with highly explicit modifiable capabilities. Last, designers can combine different elements from our other applications and solutions to increase the design opportunities. You can see here, we're linking together our sub-D elements with our Bezier curves made in IDX for quick design opportunities and changes. Let's take a closer look at the different mathematics working together like we explained in the last video. As mentioned, we use a door handle created using IME sub-D surfaces. And next we went ahead and linked the sub-D to the IDX curve feature. This will allow us to adjust the linked objects with the different mathematics all in one move. Folks, let's not forget, because you're in CATIA, you can mix and match geometry created in our other applications, like in this example, using an IMA sub-D surface door handle with an associated IDX Bezier feature. One single software for all sub-D, Class A, Viz, reverse engineering, generative design, no need to change softwares or data import or export. This next demonstration shows how you can quickly expedite the process for feasibility surfaces for our design and studio engineers. So again, I quickly went ahead and created some curve networks. I'm going to use these in conjunction with a series of surface networks and the mesh in order to create an automatic and semi-automatic surface. So what we did here, folks, is we grabbed the curve networks, we select the mesh, and we're telling the system to go ahead and create an automated surface based on the parameters that we bake in. So we add a tolerance of 1 millimeter here, and we're going to pick sharp edges. And what the system's going to do is it's going to use the curve networks and the mesh, and it's going to go ahead and expedite the process to build an automatic surface directly on top of the scan. In the end here, what we're going to do is we're going to use a series of tools. First, we're going to use a tool to go ahead and check the deviation between the scan and the new automatic surface. Again, you'll see some red zones that will show that we've went beyond the 1 mil criteria. These are things that we can go back and work. If we wanted to go back and change the curve network to make these modifications to fix things, we could go ahead and do that, or we could just leave the surface and use it for what it's worth. Last, just to show you the quality of the surface, I'll shut this deviation chart off, and we can go ahead and see the quality of the surface. Notice it's a very clean and very usable surface for feasibility. All right, folks, for this next demonstration, this is for the Class A experts. This is going to be a typical workflow using scan data and IDX together. So we're going to begin this job using the embedded reverse engineering tools in IDX to create the character lines that define our object. We'll use the fictive edge tool in parallel with the contrast map tool as the visual aid. This is in order to place the points on the mesh that represents the character line. Next, we'll create temporary display lists for each fictive edge reference curve in order to create accurate new OmniCurve guides that will associate our main slab surface edges with our newly created Bezier curve lines. Now we'll create our main surfaces using Omnisurf. This is a single surfacing tool that creates a surface based on the elements you select. Because only we selected 2 rails as our construction elements, the result could only be a blend surface. Fast crown menu hotkey control point modification tools can be easily accessed for quick on-the-fly geometry adjustments as seen here. Again, we explore shapes by global modeling using the universal laws to define the right shape without even moving any individual control points. Look how close we are to the scan now just by making some minor adjustments and quickly capturing the shape. This is a very dynamic workflow. This is our new Omnisurf technology for filleting. As you can see, I'm making a variable fillet, and I'm using a graph here just to go ahead and blend the surface. We'll see some changes here. Last, we're going to go ahead and bring in some of the images, and this is in order to capture the gap. We're going to do this in a side view, and we're going to use the gap command after to go ahead and build a gap with flanges directly on top of the surface that we created in IDX. These are highly modifiable. We can go ahead and adjust the curves after and replace the gap and change the shape on the fly. The last portion that we're going to go over are some of the display modes inside of IDX. We're just going to go over these and put it in a perspective mode in order to go ahead and show our design team what we've created.
Fantastic, Bill. So thank you for this demonstration. So as you can see, the ICEM design experience is bringing unified modeling. And what does it mean? It means that we combine flexibility, so the freedom of creativity, with the power and associativity of CATIA, and of course, with the precision and the quality coming from ICEM domain. So all this combined really provides to you the specific tool you need for your daily job.
Thanks, Fabio. Just to zero back in on some of the things that we talked about earlier, I would like to talk a little more about the soft parametric side, just so folks at home understand this a little better. With IDX, you have a choice on how you want to work, explicit or associative, like we explained. For example, if you want to create explicit geometry, leave your option set on datum. This will serve all the folks in the community, traditional ICEM workers, or even CATIA users. If you don't need to have something to be fully parametric, then you can use inactive. Inactive mode is the same workflow as datum, except now your features have memory. If you'd like, you can use alert mode. This will alert you if you have changes in the feature that affect another feature, but will not update the geometry unless you force it to. Okay, folks, so these are the 3 soft parametric modes that can never be modified using CATIA update tools. So if your geometry is in any of these 3 modes, remember, updating will not affect these elements. Now, for the modes that can be updated, adaptive mode. This mode allows you to modify and tune the shapes that are connected to the shapes being modified. These will also move free and in a creative way. The rebuild mode. This mode will let you sculpt and shape, but when a large update takes place, the geometry will reset. This is like the traditional CATIA associativity that you use now. Reshape mode is when you build a feature like a blend surface created by 2 curves, but still have the option to manipulate the internal blend surface control points. This is all while keeping the connection with the elements that constructed the blend originally. Last, revert. If you're not satisfied with the sculpting changes made on the surface, you can return to the original condition during construction. just recall the benefits of these powerful applications. This is for both the surface modelers, concept to production class A people, even the morphing folks. What are the benefits to remember about this? Remember, ICEM Design Experience, IDX, is a dedicated user experience for doing surface modeling, CAS, or Class A. We created this solution to bring the industry new tools, more powerful tools, that allow users to choose the way they want to work based on their needs and their deliverables. You also benefit from being able to choose from several surfacing paths and methodologies for constructing models. And please don't forget, you still benefit from all the unified modeling technologies embedded in our other CATIA tools. This includes reverse engineering and all the CATIA surfacing tools. And last, for formal and non-formal reviews, please don't forget, we deliver a native high-end visualization tool. So now, with the 3D Experience platform, you have the realistic high-end rendering capabilities. You also now have compelling VR capabilities without importing or exporting data.
Very good, Bill. Thank you for all those details and information, and for all those demonstrations. And just remind you that we have a CATIA Creative Design and Styling dedicated community. So I really invite you to join this community if you really want to know more and exchange with our experts and others, creative design and Class A modelers. In order to do that, you just have to Google it and click on the first link you got. And then, of course, don't forget to create a 3ds passport. So it's free. You can log in. And once you're in, you can start, exchange, share your demonstration, and comment existing posts. You will also find tips and tricks and, of course, best practices inside. It's a good space, you know, to share knowledge and keep contact with other users, and also, of course, Dassault Systèmes experts. So, Bill, I think that's pretty much it for today. So I would like to thank you, the people that has joined this webinar, and stay tuned, stay connected, and have fun. Yes.
Thanks, everyone. We'll see you soon.
So now we have a 50-minute question and answer